Entering Module 2, okay? So for Module 2, you guys, we're moving on to what's known as mole to mass and mass to mole stoichiometry. So we're going to be using the same technique that we were using in Module 1, except for we're going to have, in our train tracks, we're going to have one additional conversion factor. There's going to be another fraction or another ratio that we have to work with, and that's the molar mass ratio, okay? So, again, the first thing that I told you guys, when we start any of these problems, we have to start with what? We have to start with a balanced chemical equation. You got it, Savannah. Okay? So, right here it says, in photosynthesis, plants use energy from the sun to produce glucose, which has the chemical formula C6H12O6, as well as oxygen gas, O2, from the reaction between carbon dioxide and water. So, in other words, they're telling us that our reactants are the carbon dioxide and the water. So, what's the formula for carbon dioxide, you guys? CO2. Okay, so our formula for carbon dioxide is CO2 plus, what is our formula for water? H2O. To produce, they're telling us that we produce two things. They're telling us that we produce the glucose and the oxygen gas. So the glucose is C6H12O6 plus our oxygen gas, O2. So there's our skeleton equation. We've got all of our reactants and our products in there at this point, okay? Now, we've got to check to see if this is balanced. So is this particular equation a balanced chemical equation? What's that? It seems about right. Is our carbon balanced? Not balanced, okay? So when we look on the left, we've got one carbon. When we look on the right, how many carbons do we have? 6. So how can we fix that? How can we get 6 carbons on the left? Coefficient of 6. You got it, Ben? Okay? So now we've got our carbon balanced. How about our hydrogen? On the left, how many hydrogens do we have right now? On the left? 2. On the right, we've got 12. So we've got 2 hydrogens on the left. We've got 12 hydrogens on the right. How can I get 12 hydrogens on the left? Coefficient of 6 again. You got it. Okay? So that's got our hydrogen balance. Now let's look at our oxygen. Okay? On the left, we've got 6 times 2. 6 times 2 is what? 12. Plus, we've got another 6 oxygens right here in our water. So we've got 12 here, and we've got 6 here. So 12 plus 6 is 18. And then let's look on the right. On the right, we've got 6 right here in our glucose. And then over here in our oxygen right now, we've only got 2, which gives us a total of 8. But I need to get a total of 18. Okay? So if I want to get a number right here that is 18 on the right-hand side, and I've got a 6 here and I've got a 6 here, well, what that really means is that over here, instead of a 2, what I really need to have is what? 12. Okay? So how am I going to get 12 oxygens out of O2? Put another coefficient of 6. You got it. Okay? Now, I don't know if this is trying to tell us something, but if you notice, the coefficients in here are 6, 6, 6. It's kind of suspicious. This whole photosynthesis thing is like the reaction of the devil, which is why you shouldn't major in biology.
Is Marta Anthony in this thing?
Right there.
Oh, hey, Marta.
All right. So we've got a balanced chemical equation. Okay? So now what we're going to do is I'm going to get rid of these numbers here. How do y'all like that? First it was there, and then it was gone. We just erased like a chalkboard. Okay, so after we get our balanced chemical equation, underneath the balanced chemical equation, what we need to do is we need to write the information that was given as well as the information that we are solving for. So it says that what mass of glucose. Well, which substance in this chemical equation represents the formula for glucose? C6H12O6, you got it. So our glucose is this substance right here. And it says what mass of glucose? Well, mass is typically measured in grams. So in other words, they're asking us how many grams of glucose are going to be produced when 3.00 moles of water, so let's write that down, 3.00 moles of water react with an excess of carbon dioxide. So in other words, we've got as much carbon dioxide as we need to perform this reaction, but we've only got 3 moles of water. And the question is, how many grams of glucose can we make from that? Okay? So they've told us how much we started with. The question is, how much are we going to end with? But this time, rather than ending with a mole quantity, they're asking us to put that answer into grams. So we're actually going to start this problem the same way, you guys. Anytime I want to move from one substance to another, it doesn't matter whether I'm moving from reactant to product, or whether I'm moving from a product to a reactant, or whether I'm going from a reactant to a reactant, or a product to a product. It doesn't matter, but anytime I try to move from one substance in the chemical equation to another substance in the chemical equation, I have to, as Bergman and Sam say, I have to go through the length of the mole, okay? You have to go through the mole quantity, which means that this problem is going to start out exactly like the last problems that we did in Module 1. We're going to convert moles of water first into moles of glucose. And once I convert moles of water into moles of glucose, then I can convert moles of glucose into grams using molar mass from the periodic table. We learned earlier this year, and we've used it several times, to convert between grams and moles, we always use the molar mass from the periodic table. Okay? So, we're starting out here with 3.00 moles of water. We're going to draw out our train tracks. Okay? And we've got to go first through the land of the mole, which means I need the mole-to-mole ratio between my water and my glucose. Okay? So, how many moles of water do we see based on the coefficients in the balanced chemical equation? What is it? How many moles of water from the balanced chemical equation? Not 8. Oh, no, not 18. 6. The coefficient in front of the water is 6. So, I've got 6 moles of water, and you guys, that literally just comes from that coefficient in the balanced chemical equation. Okay? 6 moles of water produce, you guys, now we need right here, what is that coefficient in front of the glucose? 1. When there is no coefficient, the coefficient is 1. So we produce 1 mole of glucose, C6H12O6, for every 6 moles of water that are consumed. And by setting it up with moles of glucose on top and moles of water on the bottom, the moles of water unit cancels out. So we have just crossed over, as Bergman and Sams like to say, the land of the mole. We've converted from moles of one substance to moles of another substance by using the coefficients in the balanced chemical equation. Those coefficients give us the mole-to-mole ratio between the reactant and the product.
So how can that water compound be 6 moles and 3 moles at the same time?
Okay, so the 3, Hunter, the 3 is the quantity that we are given. So they're literally telling us in the lab we've only got 3 moles of water to use. The 6 in front of the water is the coefficient from the balanced chemical equation. So they are 2 different things. One is actually a measured quantity that 3 moles of water is a measured quantity, and the 6 is simply a ratio from, meaning the coefficients from, the balanced chemical equation. Okay? But what that ratio from the balanced chemical equation allows us to do is it allows us to convert that measured quantity of water now into a measured quantity of glucose. Okay? Using those coefficients from the balanced chemical equation. All right? So now, we're not done with this problem. We've now got moles of glucose. But the unit that they asked us to solve for was not moles of glucose. What they asked us to solve for was grams of glucose, not moles, grams. So we need to convert moles of glucose into grams. And the way to perform a gram to mole or mole to gram conversion is using the molar mass of the substance from the periodic table. So what we've got to do is we've got to go back here and calculate a molar mass for the glucose, the C6H12O6, okay? So we've got to do another problem, all right, to get the molar mass of C6H12O6. So what we're going to have to do is we're going to have to take the molar mass of carbon and multiply it by what? What is the subscript for carbon and glucose? What is the subscript for carbon in glucose? 6. So we're going to need to take the molar mass of carbon and multiply it by 6. We're going to need to take the molar mass of hydrogen and multiply it by what? 12. And we're going to need to take the molar mass of the oxygen and multiply it by what? 6. And then I'm going to add all of those together. And that's going to give me the molar mass of C6H12O6. Okay? We have to keep going, yes. Okay? But before I can continue, I need the molar mass of the glucose. So, like I was saying, we've got to do, so let's see. I need to erase a little bit here so that I can do a molar mass problem. Okay? We're going to clear the slide. Okay? We've got to do the molar mass of C6H12O6. All right? So like I said, we need the molar mass of carbon, which is 12.01, and we've got to multiply that by 6, and the molar mass of hydrogen, which is 1.01, and you guys said we needed to multiply that by 12, and the molar mass of oxygen, which is 16, and multiply that by 6. And again, you guys, where am I getting all of those numbers? The 12.01, the 1.01, the 16, where do they come from? Those are the atomic masses off of the periodic table, okay? So those numbers all came from the periodic table, all right? So what we've got to do is we've got to use a calculator right now to add up all of those masses, okay? And when I do that, I believe you guys double check me, but I think the number we might get is 180.18 grams per mole.
I got the same except I got 0.06.
You got 0.06? Well, here, this would be 0.06, this would be 0.12, and then this one would be 0.06 again. Okay. And so let me double check and see what I get there. Let's see, 12.01 times 6 plus, that's going to be 12.12 plus 16 times 6, whoops. I'm getting 0.18. Yep. Okay? So that looks good. So we've got our molar mass now. Okay? So what we had was we had, in our little train tracks, we had 3 moles of water. Okay? And we had, what was it, 1 mole of glucose over 6 moles of water. Am I right? Okay, so moles of water canceled out. Now what we've got to do is use that molar mass. Okay? When we are trying to convert from moles to grams, we multiply by molar mass. So going from moles to grams, we multiply by molar mass. if I were going from grams to moles, would I multiply by molar mass? If I were going the opposite direction, what would I do? I would divide, exactly. So if I were going from grams to moles, I would divide by molar mass. But here I'm going from moles to grams, so I need to multiply by molar mass. So that's 180.18 grams of glucose, C6H12O6, over 1 mole of glucose, C6H12O6. I just put the molar mass in the form of a conversion factor, okay? Grams per 1 mole. And now what you'll notice is that the moles of glucose cancels out, and I've got on top grams of glucose, C6H12O6, which is what they asked me to solve for. So remember, all the things that go across the top, we multiply. The stuff that's in the bottom, we divide. So what we're going to type into our calculators is we're going to type in 3.00 times 1 times 180.18, and then I'm going to divide by 6, because that's what I've got in my denominator, or divided by 6 times 1 if you want to put it that way. Okay? So, how many significant figures did we start with in the number 3.00? How many significant figures is that? I think I heard 3, right? So 3 significant figures. So if I started with 3 significant figures, how many significant figures do I want to end with? I also want to end with 3. Okay? So when I type that into my calculator, 3.00 times 1 times 180.18 divided by 6, I get 90.09, and that's grams. How can I round the number 90.09 to 3 significant figures?
You do 90.1.
Good. 90.1 grams of glucose is our final answer. Okay? So the 9 right here tells us to round that 0 up to a 1. 90.1 grams of glucose. Okay? So, very similar to what we did in Module 1, it just has one additional step. And that additional step is the molar mass step. Okay? The first step was exactly the same. We converted from moles of one substance into moles of another substance. That's called crossing the land of the mole. And then we added this new step here. We multiplied by the molar mass to convert moles of glucose into grams of glucose. So that's an example of a mole to mass stoichiometry problem, okay?